Hello students, today we are going to talk about two terms important in this chapter, permeability and susceptibility. We shall be talking about it more frequently in this chapter, so we need to understand these two terms very nicely. Well, you see, what is permeability? Permeability of any medium is an index which tells us that how many magnetic field lines are allowed to pass through the specimen or the sample when it is placed in external magnetizing field. And mathematically we derive it as the ratio of intensity of total magnetic field produced by the core material to the intensity of magnetization produced in the core material. We have already learned that what is intensity of magnetization. It is total magnetic dipole moment per unit volume produced in the sample, and this ratio is known as permeability. It is constant for a given material. For air medium we use the symbol mu0, and if we have some another medium we use mu, where B is the total magnetic field produced inside the core material when a sample is placed inside the, say, solenoid, which is producing some uniform magnetic field at its axis and around the axis. When a specimen is placed over there, then the total net magnetic field produced by the specimen to the intensity of magnetization produced in the specimen, this ratio is known as permeability. And it is also defined as the ratio of total magnetic field inside the specimen to the external magnetizing field applied over the sample. And therefore we have B is equal to mu H. This relation is between total magnetic field produced by the core material and H is the external magnetizing field. Now we define susceptibility. Symbol is chi, and for permeability symbol is mu. For susceptibility symbol is chi. It is defined as the ratio of intensity of magnetization to the external magnetizing field. So chi is equal to m upon h. Chi is a scalar quantity, and if we have h value is 1 Tesla, if we take the external magnetizing field to be of 1 Tesla, then chi is numerically equal to intensity of magnetization. That means chi is numerical to intensity of magnetization, and therefore we can define susceptibility is numerically equal to the intensity of magnetization of the specimen which is placed in a external magnetizing field of a strength 1 Tesla. If a core material, if a sample is placed in some external magnetizing field of 1 Tesla, then whatever intensity of magnetization is produced in the core material, that is numerically equal to susceptibility of the material. That's all for today. Thank you and have a nice day.